So in this project, it's called post-harvest dawn reduction strategies. So farmers have options to try to keep Fusarium from affecting their crops. And so there's different variety selection, there's some fungicides they can use. But sometimes we get the disease no matter what we try. And when you get the disease, what do you do with that crop? It takes 1-2% infected material to reduce the value to very low levels. And so what we want to do in this project that's funded by ADF is look at what kind of processes can we use that will remove the toxic grain so we can get as much value out of the remaining. And when Fusarium infects the kernel, it changes the characteristics of it. It can change the physical characteristics, it can make it lighter. And so there's technologies, we were partnering with Flamin Grains. They allowed us to use a number of their grain cleaning systems to figure out what would be most effective. One was to use something called an air fractionator, which is a unit, it's a grain cleaning system that separates grain based on density. And using that, we could take out a lot of the really light, heavily infected grains. But then there's some grains that don't change much visually. They don't change much from a density perspective, but the chemical compositions change because of disease. So then we were able to use this machine here, and we have a larger one at our plant, a 3-ton-an-hour unit, called a bow mill. And what it does is it sorts grains individually based on near-infrared transmittance. Big word. When you go to the elevator, sell your grain, they put it into a machine and it tells you the protein content, tells you the moisture content, based on shining some light on the sample and coming up with a value. This machine does the same thing, except for it's on an individual seed basis. So it looks at every seed, and my big unit's 30,000 seeds a second, I think it is. It's a whole bunch, it's 3 tons an hour. Every seed is analyzed to determine if it has Fusarium or not. And then there's a little air nozzle that kicks it out if it does. And so we're able to sort it. So this little lab unit allowed us to try all kinds of conditions before we scale up to the large unit. And so it's an example of a technology that takes us one step further. So using air fractionation alone, we could recover in some material that was about 10% Fusarium damage. We could recover about 50% of the grain using air fractionation, sort of classical methods. But there was still a portion of that grain that is still good, but we couldn't get at it because it wasn't different based on density. This was able to take another 20-25%. So we ended up with like a 70-75% recovery of our grain using a combination of the two technologies.